Okay, let's unpack this. We've got a really interesting source today. It's a blog post from the Microsoft Security blog.
Ah, yes, the one by Yonatan Zunger there, Deputy CISO for AI, How to Deploy AI Safely.
That's the one. It's a great starting point for what we want to do here.
It really is. It gets quite practical, which is helpful, not just theory.
Exactly. And that's really our mission for this deep dive. We want to pull out the core ideas for deploying AI and other new tech, actually, safely. But we're really looking at this through a specific lens.
The public service lens, right, for folks here in Canada.
Precisely. How does this stuff apply to you if you're working to make things better for Canadian citizens every day? Because, bringing in new tech, especially something like AI, it's exciting, no doubt.
Oh, absolutely. Transformative potential.
But it also comes with, well, potential pitfalls,
Hmm.
big ones sometimes. So think of this deep dive as maybe a shortcut for you, helping you get a handle on what could go wrong.
And crucially, what kind of plan you need. It's all about making sure that when government adopts these powerful tools, they actually serve the public good, safely.
Effectively.
Right. So let's jump right in. The post kicks off by defining what deploying safely even means. And it's not about perfection, is it? Like guaranteeing nothing can ever break.
No, not at all. That's maybe the first big takeaway. The source is really clear. Safe deployment isn't about preventing every single failure. That's probably impossible.
Okay.
It's more about understanding as many potential problems as you can before they happen, and then having solid plans for those scenarios. Building in resilience, really.
Resilient. So if something does go wrong, it doesn't blow up into a huge incident.
Exactly. And being ready to handle the unexpected stuff, too, the things you didn't see coming.
Okay, so it's less about perfect prevention, more about preparedness and elective response, managing issues.
Precisely. And the source immediately flags something really vital. Safety isn't just a tech problem. Like, it's not just about the code.
Well, you have to think about things like privacy failures or unexpected user behavior, how people might use the system in ways you never intended.
Yeah. People are unpredictable.
Totally. And the wider organizational impacts, too. The source makes the point that no single team, not security, not privacy, not the devs, owns all of this alone.
Right. It's a shared thing, systemic. Which, speaking of the system, brings us to these 4 basic principles the Post lays out. They're tech agnostic, apparently. Apply to anything new, not just AI.
Yeah, foundational stuff. The first one is pretty straightforward. Understand what might go wrong, all the potential failure points.
Okay.
And for each one you identify, have a real plan. That plan might mean changing the system design itself, maybe making parts fail more gracefully.
Fail gracefully, so one small break doesn't crash everything else.
Exactly.
Mm.
Or it could mean having good detection tools and, processes ready to respond quickly.
Identify risks, plan your countermeasures or responses. Makes sense.
It does. Now, the second principle is where that entire system idea really comes in strong. You have to analyze the whole thing. And that explicitly includes the humans involved.
The people using it, the people affected by it.
Yes. And the full business process around it. Things that might go wrong isn't just like software bugs. It's anything that might need a response. Even, as the source puts it, ending up on the front page of the paper.
Oof. Yeah. And that hits hard in a government context, doesn't it? For a public servant, the entire system isn't just the software.
Right.
It's the existing processes, the policies, how colleagues use it, how citizens interact with it.
Absolutely. The impact on people's lives.
Right. And ending up on the front page in government, that often means a serious breach of public trust. Or, someone getting denied a benefit they need or getting wrong information because the system messed up. Real harm.
That scale and human impact just magnify the need to see that whole picture. The policy context, the human touch points, everything.
Okay, principle 3. The safety thinking. It's not an afterthought, right? Not
No.
just a box to tick at the end.
Definitely not. You need to be thinking about what could go wrong right from the start, from the moment you even consider using a new technology,
And keep doing it.
continuously,
Yeah.
throughout the whole life cycle. Planning for failure needs to happen right alongside designing the features you actually want. It has to evolve as the system evolves or as you learn more.
Okay, ongoing vigilance. And the 4th principle kind of formalizes that, making a written safety plan.
Exactly. Documenting the risks you found, your plans for dealing with them, and importantly, a clear description of the system itself. What is it for? What problem does it solve?
That written plan feels crucial, especially in large organizations, like government departments reviewing lots of different projects.
For sure. Having some kind of standard format, maybe using existing governance templates, makes it much easier for oversight folks to get up to speed quickly on the risks and the plans. It's tangible proof of the safety thinking.
So these four things: understand risks and plan, analyze the whole system, including people, do it continuously, write it down, pretty fundamental safety engineering.
They really are. The tricky part with something new like AI is figuring out how these principles apply, because AI introduces different kinds of potential failures.
Right. Which brings us nicely to the AI-specific stuff. This is where it gets, well, different from traditional software.
Yeah, this is the core insight, I think. With many AI systems, error isn't just a bug you can eventually squash completely. It's intrinsic, part of how it works.
You mean things like hallucination?
Exactly. Hallucination, where the AI just makes stuff up, or prompt injection, where someone tricks it. These are inherent possibilities. The source makes a critical point. If your system absolutely must be deterministic,
Deterministic meaning.
meaning the same input always gives the exact same perfectly correct output, like a calculator.
Gotcha.
If you need that level of perfect consistency, AI might just be the wrong tool for that job.
Wow, okay. That's a big caveat. You can't assume perfect output.
Right. Which leads to this really helpful analogy they use. Don't think of AI like your most seasoned, reliable senior expert. Think of it more like a well-intentioned but inexperienced new hire.
Huh. Okay, I can picture that. Eager, smart, but maybe trips up sometimes.
Precisely. Enthusiastic, capable of a lot, but yeah, occasionally makes basic mistakes, misinterprets things, lacks that deep judgment that comes with experience.
Okay, that framing helps.
But here's the kicker. We already know how to build really reliable systems, complex organizations, government services out of components that aren't perfectly reliable, namely us, people.
Ah, right. We build checks and balances into human processes all the time.
We do. We have oversight, reviews, multiple sets of eyes. We build processes that account for potential human error. So the playbook for managing fallibility isn't entirely new.
Okay, so we adapt that playbook. Now, the source goes into the specific types of errors that can pop up in any analysis or decision-making, really, whether it's a human or an AI doing it.
First, the classic. Yo, garbage in, garbage out.
If the input data is bad,
The output's going to be bad. Simple as that. If an AI is processing a citizen's application using flawed data, the result will be flawed. Obvious? Maybe, but critical.
true. What's next?
Misinterpreted data. This one's subtle. The source has a good example about loan analysis. Imagine the system expects data on mean duration of continuous employment, but gets data on mean duration of each job.
For someone like a contractor with lots of short digs, those numbers would be wildly different.
Exactly, leading to a totally wrong assessment. Now think about public service data, maybe data about a citizen or a program. A field might mean one thing in System A, but something slightly different in System B. An AI could easily misinterpret that.
And make a wrong decision about eligibility or service delivery based on that subtle misunderstanding. That seems particularly dangerous because it might not look wrong on the surface.
Precisely. It hides. Third is hallucination. False positives, basically. The AI introduces information that just isn't in the input data. It invents a detail.
Which could send, say, a public servant caseworker down a rabbit hole, chasing something that doesn't exist. Wasting time, maybe making errors.
Right. Fourth is the opposite. Omission. False negatives. The AI leaves out critical context, or maybe a crucial caveat or exception.
So it summarizes regulations but misses the one exception that applies to the specific citizen's case.
Exactly. And missing that could lead to applying a rule incorrectly, harming the citizen.
Okay, and the last one.
Unexpected preferences. Any summary or recommendation has biases, implicit priorities. Does the AI prioritize what you intended based on policy? Or does it latch onto something else, something maybe irrelevant or even counterproductive?
Making sure the AI's choices actually align with the intent of the government policies seems absolutely crucial for fairness.
It's paramount. So, G.I. Joe, misinterpretation, hallucination, omission, unexpected preferences. These are the error modes.
Applicable to humans and AI analysis.
And recognizing that similarity is the key to the AI-specific safety rules. It flows from that understanding.
Rule 5, then, builds directly on that new hire idea.
Yep. Reason about AI safety by imagining replacing the AI component with that room full of enthusiastic but inexperienced new hires. How would you build safety into the process then?
You'd want checks and balances, right? Oversight.
Exactly. It doesn't necessarily mean a human reviews every single output, but you find those strategic points, maybe for high-stakes decisions, or where getting a second opinion from a more experienced person or even a different AI makes sense.
So for public servants, it's like looking at existing review processes. If a manager signs off on complex human decisions now.
Maybe that same manager needs to review when an AI assists with those decisions. You apply the same logic of oversight.
Got it. Applying known principles. Rule 6 is about testing.
And how much time it takes. Expect testing to take way more time than coding, much more than traditional software. AI development is often this cycle of prototype, break it, fix it.
So you need tons of test cases.
Extensive ones, covering not just the intended use, but also, confuse users. What if someone puts in weird input? And definitely threat actors. How might someone try to deliberately misuse or trick it? Functionality testing and security testing really blurred together here.
For government departments thinking about using AI tools, this sounds like a call for serious rigor, demanding thorough testing from vendors, maybe doing lots of internal testing focused on real-world citizen scenarios before anything goes live.
It's absolutely non-negotiable when public services are on the line. Testing isn't a nice to have.
Okay. Rule 7. Decision-making criteria need test cases too, whether for humans or AI prompts.
Yes, and crucially, those test cases need validation. Get multiple people to evaluate them independently using the criteria. Do they agree? Does their interpretation match the intent?
This feels vital for fairness and consistency. If an AI is helping decide program eligibility, the definitions, what does income mean, what counts as resident, have to be unambiguous.
Exactly. And testing those definitions with hypothetical cases helps catch misinterpretations before the system makes real decisions affecting citizens. You tweak the criteria until everyone agrees on how they apply.
And policy experts should be involved in creating these.
Deeply involved. The source suggests they provide initial test cases. AI might help generate more variations, but humans still need to validate the expected outcomes against the policy intent.
Makes sense. Rule 8, monitor and cross-check decisions continuously.
Yeah, don't just set it and forget it. Send a random sample of decisions for review, maybe by humans, maybe other AIs. Track the agreement rate.
And escalate disagreements, or high-impact cases.
Absolutely. Disagreements need investigation. And high-impact cases like the source's large loan example, or for government, maybe a major benefit determination or a complex compliance assessment should probably get escalated to more experienced people for review.
And log everything. Monitor revealed preferences.
Yes, careful logging is key. Monitoring revealed preferences means watching what the system actually prioritizes over time, not just what you told it to. Is it drifting? Developing unintended biases? This continuous oversight is crucial for maintaining fairness and alignment with policy goals.
Sounds like ongoing quality control and auditing combined.
Pretty much. And finally, Rule 9. Present information carefully, especially when it crosses a people boundary.
Meaning from machine to machine or machine to human.
Exactly. You need to invest heavily in clarity. For machine to machine, that means really clear, well-defined APIs, the rules for how systems talk. For machine to human, it means extremely clear user experience design.
So if an AI gives info to a public servant user, that info has to be crystal clear, no ambiguity.
Because if the human misunderstands the AI's output, maybe the interface is confusing or the language is jargon-filled, the AI's value is lost. Worse, it could lead to a human error that then gets blamed on the AI.
Right. The public servant needs to trust and correctly interpret the AI's input to make the right call for the citizen. Clarity at that handoff is critical.
Absolutely critical. Prevents downstream errors.
So looking back at all this, the really big takeaway seems to be that these novel technologies, like AI, they don't actually create entirely new safety problems out of thin air.
It's not fundamentally no.
They just demand that we get back to basics. That we execute those foundational safety principles, understanding risks, seeing the whole system, planning, checking really, really well with diligence.
That truly feels like the deepest insight here. AI isn't magic. It just requires more rigor in applying what we already know about building safe systems, paying close attention to AI's specific quirks and how it interacts with people.
Okay, so thinking about all the principles, the potential errors, the whole system view, the human-like checks. Here's something to chew on for you, the listener, especially if you're in public service.
Yeah.
How can these ideas help you not just deploy AI safely down the road, but maybe even improve the processes you use right now to serve Canadians, even the non-AI ones?
That's a great point. Because good safety thinking, good process design thinking, it's often about understanding potential failures and human factors, regardless of the tech involved.
Right. Maybe looking at your current work through this lens, where are the potential misunderstandings, the omissions, the points where clearer information or an extra check could help?
Because ultimately, safe systems and effective public service rely on applying these foundational ideas carefully, especially paying attention to how things work on the ground with real people.
So think about your own work. Where could these principles apply? The source does mention deeper resources and a video example too, which might be useful next steps if you want to dig in more.
Definitely worth exploring if this has sparked some ideas.
Okay, that wraps up this deep dive.